Hello everyone. Today we are back with another interesting potential JEE problem. The problem today we have is of probability, that is the sum of the digits of a 7-digit number is 59, and what is the probability? It is divisible by 11. So today I am not gonna use multinomial theorem procedure here to find the number of integral solution of an linear equation here. Because I am assuming that the students that are watching it do not know that. Okay, so what we have to find, there is, let us suppose there is a 7-digit number. The digits are x1, x2, x3, x4, x5, x6, x7. So what is the basic rule? That x1 must be it can assume the value from 1 to 9, and x2, x3, x4, x7 can assume the value from 0 to 9. Two things what we need to find out is favorable outcomes and sample space. Let us go first to sample space. Okay, so here we can see that the sum of the digits we are given equals to 59. Now 59 is a big number. If you see here that suppose that the maximum the sum of the digits can assume is 7 into 9 equals to 63, assuming that all the digits have value 9. Now what I am actually saying here, that there has to be at least 3 digits whose value equals to 9. Okay, now why I am saying that, suppose that there are only 2 digits whose values are equal to 9. Okay, so the rest of the 5 digits, suppose x6, x7 has the value 9, so x1, x2, x3, x4, x5 can assume the maximum value of only 8. They cannot be 9, so because there are only 2 digits that have the value 9. So that counts up to 9 plus 9, 18, and 59 minus 18 equals to 41. Now they have maximum, assume the number 8, so 8 into 5 equals to 40. The maximum, the sum of these digits can go up to 40, but here we are seeing that the 59 minus 18 is coming to 41. So we can safely say that at least 3 digits must have the digit equals to 9. Okay, so we will start that suppose that there are 6 digits whose values equals to 9. So 9 plus 9 plus 9 plus 9 up to 6 times, plus x7, suppose x7 assume the value 0 to 8 equals to 59. So the value of x7 equals to 59 minus 9 into 6, that is 54, equals to 5. So how many solutions are possible here? We know that since 7 digits mean, suppose 7 boxes, then 7 factorial by the rule of permutation. We know that 7 factorial, and since 6 items are identical here, so 7 factorial upon 6 factorial equals to 7. Now assume that there are only 5 digits whose value are 9. So 9 into 5 equals to 45. Suppose x6 and x7 has the maximum value up to 8. Okay, then 59 minus 45 equals to 14. So x6 plus x7 must be equals to 14. So how many integral values are possible here? We know that maximum they can go up to 8. So 8 and 6 is one value, is one solution, and 7 is the one solution. Okay, now if we go less, suppose we take one value equals to 5, then other has to be 9 or 4 10. So we know these are the only solutions we are left with. So what we can say, 9 digits are 5 and 8 6. So by the rule of permutation, 5 are identical items here, so 7 factorial upon 5 factorial equals to 42. And here is we can see 5 are alike and 2 are alike, so by the rule of permutation we can see the total number of solution is 7 factorial upon 5 factorial into 2 factorial, that is 7 into 6 upon 2 equals to 21. Same goes to 4 digits, then 4 into 9 equals to 36, 59 minus 36 equals to 23. So x5 plus x6 plus x7 equals to 23. The only possible solution, why? Because the maximum they can assume is 8 plus 8 plus 8, 24. Only one is less from 24 here, so 887 is the only possible solution. So what is the number of solutions there? 887, that is 7 factorial upon 4 factorial into 2 factorial. So the value comes, number of solutions comes 105. Now the last case is, let 3 digits equals to 9. So 9 plus 9 plus 9, 27. Then x4 plus x5 plus x6 plus x7, they all can assume maximum 8. So 59 minus 27 equals to 32. Then 8 into 4 we know equals to 32. So the only one solution is 8, 8, 8, 8. So 7 factorial upon 4 factorial into 3 factorial. So what we are came with 35. So total number of solutions will be for 6 digit, for 5 digit, for 4 digit, and for 3 digit. So how many solutions are there? 7, 14, 40. Sorry, not this. I'm sorry. 7, 42, 21, 105, and 35. So total number of solution here is 7 plus 42 plus 21 plus 105 plus 35 equals to 210. So sample space we have taken what sample space here comes of 210. Now we have to find favorable outcomes. Now we know that a 7 digit number can be written as 10 to the power 6x1 plus 10 to the power 5x2 plus 10 to the power 4x3 plus 10 to the power 3x4 up to x7. So to find what we have to find, what is the probability it is divisible by 11. So how can we find out if it is divisible by 11? So we assume that we can write 10 as 11 minus 1 and open these these terms from binomial expansion. Now by binomial expansion we know that when we open this, all other terms except x1, because the 1 that is come, suppose 11 c0, that is the term 1 plus 11 c1 x plus x1 plus 11 c2 x2, these all terms will be divisible by 11. Only term left with 1. Okay, since 6 here is even, so the 1 will be positive here. So x1 here, 5 is odd, so 1 that came after the expansion here will be negative. So x1, similarly for all other terms, x1 minus x2 plus x3 minus x4 plus x5 minus x6 plus x7 must be equals to 11 into d. Now we know that maximum these values can go up to 9. Okay, so what is the maximum? This term, that is x1 plus x3 plus x5 plus x7, we have actually separated minus and plus terms. So all these values are positive. So maximum it can go up to 36 if we assume that these all terms have taken the value 0. We just have to find the maximum. So maximum it can go up to 36. So 11d here, what we can conclude that maximum this value can attain is 33. So what is the possible value of d here? 0, 1, 2, 3. Only these d can assume up to 4 value till now. Now what we are given with, we are given that x1 plus x3 plus x5 plus x7 plus x2 plus x4 plus x6 equals to 59. Now what we are going to do, that suppose this is equation 1, this is equation 2, we are going to add this. So what we are left with, 2x1, x2 plus x4 plus x6 will cut from here, right? So what we are left with, 2x1 plus x3 plus x5 plus x7. Now the left hand term is even, it is an even number, right? So we have to keep there that we have to choose d such that it has to be even at right hand side also. Suppose d equals to 0, then 59 will be odd, then d equals to 0 can be eliminated here. Why? Because left hand term has to be even. So to make it even, only two cases are possible, d equals to 1 and d equals to 3. As you can see, d equals to 1 if you take, then what will come? 59 plus 11, that is equals to 70 will come. We take d equals to 2, so 59 plus 11 into 2, 81, it will come odd, right? So we can reject d equals to 2. D equals to 3 is 59 plus 11 into 3 equals to 92. Now if we take 92 here, then x1 plus x3 plus x5 plus x7 must be equals to 92 upon 2, that is 46, but maximum they can go up to 36. So d equals to 3 will also get eliminated. So d equals to 1 is the only possibility here. Now d equals to 1 means x1 that is x1 plus x3 plus x5 plus x7 into 2 equals to 70, that is x1 plus x3 plus x5 plus x7 equals to 35. Now what is the possibility here? Total number of solution for x1, x3, x5, x7 here is, since maximum they can go up to 36, only 1 is less here, so we can only take 9998 here. So what is the number of solution here? Is 4 factorial upon 3 factorial, that is equals to 4. Now we have to find about x2 plus x4 plus x6 here. Now what we were given with, the sum of the digits equals to 59. So what value we have got for x2 plus x4 plus x6 here? That comes 59 minus 35 equals to 24. Now x2 plus x4 plus x6 equals to 24. So what is the possible solution here? We start with maximum 996. Okay, so total number of solution will be 3 factorial, since 2 are identical here, so 3 factorial upon 2 factorial equals to 3. Another solution is 987. 987, since all are distinct number here, so total number of solution equals to 3 factorial equals to 6. And the last one is 888. Only one solution here is 3 factorial upon 3 factorial. So 3 factorial upon 3 factorial equals to 1, right? So none other solution is available. Why? Because if we take 7, if we take 2 7 here, 7 7 14, send 24 minus 14 equals to 10. Maximum value they can attain is 9. So we know that only these terms can be possible here. So 3 plus 6 plus 1 equals to 10. Although we can solve it easily with multinomial theorem, but I am assuming that students don't know about the multinomial theorem. That's why I am actually explaining it too far. It's so far. So the total number of favorable outcomes is 10. Here is 10 came, and the possibility for 35 is 4. So by the multiple rule of permutation, we know that total number of favorable outcome will be 10 into 4 equals to 40. So what is the probability is favorable outcome upon total outcome, that is 40 upon 210, that is equals to 4 upon 21. So if you like this video, you can like this video, you can subscribe for the channel. If you have any problem, you can ask in the comment section. Thank you.